90-degree turn, and then I'm forced to go straight, and then have a 90-degree turn, and then go straight, and then have a 90-degree turn. Here I have a few 90-degree turns in a row, and that's the general structure. And can I still solve it? Maybe. The goal is to get into a cube. Okay, and plastic, wood, whatever, this one is not solved, and so I will not do so well, but you get an idea of what it looks like in its sort of flat state. You can make it into a staircase. So in general, this puzzle is specified by a sequence of lengths of straights, and then in between those lengths are the 90-degree turns. Okay, so that's the puzzle. Pretty simple specification. And your goal is to fold it into a cube. You know how big the cube is. You can figure the number of cubes. And this puzzle maybe is at least 1990, but could be older. Not exactly. And this puzzle is also NP-complete. And this proof is also complicated, so we won't see all the details, but this one we'll probably see a little bit clearer. This is a proof by, in particular, the three of us, and Marty and Shrek, so all four of us. And let's see. So this doesn't look like a cube. So before we try to solve the problem of folding into a cube shape, let's suppose I give you one of these chains, and I want to, can it fold into this shape? Let's say this is the target. So it's a big box down here. It's called a hub, and then there are these spokes, or just big boxes, long boxes, sticking out of the hub. There's a hole here. They're connected to the main structure, and you want to fold that. And let's see. So the big idea, we're reducing from three partition here. We're going to represent a number AI as a zigzag. Well, no, sorry, I shouldn't call it a zigzag. But we have a really long bar, then a length 1 bar, and then a really long bar and a length 1 bar. I'm drawing sort of the thinned version. This is really a little cube. This is a little cube. These are lots of cubes. Huge number of cubes. Okay. So that's really, really big. So big that the only place it could fit is down one of these spokes. So, of course, the idea is that these represent our triples, whose sum is equal to t. And so we have to take these things, and because these are so short, you can't, like, go out of one hub and, like, jump to the next one, because there's a gap there that's bigger than 1. So once you commit to having one of these long bars into one of these pockets, then all of them have to go into the pocket. So this is, in general, a big issue with three-partition proofs, is you want to represent the number AI in some way that cannot be, is not divisible. If you could take AI and split it into two parts, then the packing problem becomes trivial. You split everything into units or something. So we have to make sure AI remains a single chunk. We are, of course, encoding AI in unary here, because we have one long bar per each AI, but for three-partition, unary is okay. There's some things going on here a little bit weird. So you see this